Hello, my name is Ben Parmer, and this is my Project 1 presentation. I have never used MATLAB before. This is my first time using it, so I kind of use this project to gain some familiarity with the program and with coding, and I decided to do something fairly simple just so I could understand it a little better. So I basically took what we learned in class and just played around with the numbers to make my own shape. The shape I went up with on paper was a column that was 2 feet by 2 feet by 8 feet. And to define that here in the MATLAB code, I set the origin to 0, 0, 0, and the x1 max to 2, the x2 max to 2, and the x3 max to 8. Then I did 5 grid points in each dimension, defined the parameter on the grid, and then the surface, which was 6 faces, since it's a column and a rectangular box shape, and then the 12 edges, again, since it's a rectangular box shape. And then here's what I ended up with. You can see the origin is right here, and then 2 in the x direction, or the x1 direction, 2 in the x2 direction, and then 8 in the x3 direction. Next, I moved into the parameterization of the column. I did this just like what we did in class, just followed the example. And then I was able to come up with the equations you see here, which I'll talk more about in a little bit. But since we had to do a curve and then a surface, just put one segment for the curve in terms of C, and then one segment for the surface in terms of S, and one segment for the surface in terms of T. And then here, once we got those, the curve and the surface added in here, you can see them drawn, the curve in the red, and then the surface is the blue rectangle here that bisects diagonally through the column. Just to feel confident with the MATLAB code and with my hand methods of parameterization, I went ahead and calculated this just to verify. As you can see, the curve equations here are set with x1 equal to 2c, x2 equal to 2c, and x3 equal to 8c. And then using the equation, I was able to find the length of that curve. And this right here is the derivative of c with, the derivative of x1 with respect to c, the derivative of x2 with respect to c, and then the derivative of x3 with respect to c. Square all of those and then take the square root and then the integral from 0 to 1, and then you end up with 8.485 feet, which is exactly what the MATLAB code also showed. Then for the surface, I had equations. The equation for x1 is equal to 2s, the equation for x2 is equal to 2 minus 2s, and then the equation for x3 is equal to 8t. Using the equations from class, I got the vectors 2, -2, and 0, and that is the derivative of all the x's with respect to s. And then this one right here is the derivative of all the x's with respect to t. Then you take the cross product of those vectors, you end up with 0, -16, -16. Take the norm, and then the double integral with respect to s and t from 0 to 1, and you end up with 22.62 square feet, which is also exactly what I got in the MATLAB code. But that's all I have. If you have any questions, please shoot me a message. Thank you.